In our last episode, we explored the astonishing world of quantum sensors, devices that can see through walls, track submarines, and measure the invisible. But while these sensors are quietly redefining the way we observe the world, another quantum revolution is brewing, one that could transform how we share information, keep secrets, and protect the very backbone of the modern internet. This is the story of quantum communication, the technology that may soon make hacking obsolete. It begins, as always, with something strange. In 1964, physicist John Bell proposed a mind-bending idea, that if two particles are quantum entangled, changing one will instantly affect the other, no matter how far apart they are. Einstein called it spooky action at a distance, and for decades, it was considered too weird to be practical. Until someone decided to try it with information. In today's world, digital security depends on encryption, using complex math to scramble data, and secret keys to unscramble it. Most modern systems rely on RSA encryption, which uses massive prime numbers to protect everything from bank transactions to military secrets. But here's the catch. All of it depends on one simple fact, that it's really, really hard to break those keys. And that fact is starting to fall apart. Because quantum computers are coming. And they're not just fast, they're fundamentally different. A powerful quantum computer could, in theory, crack today's encryption in minutes. What was once unbreakable becomes laughably easy. Enter quantum key distribution, QKD. Unlike traditional encryption, QKD doesn't rely on mathematical complexity. It relies on physics, specifically, the no-cloning theorem of quantum mechanics. That means, in short, you can't perfectly copy a quantum state. And if anyone tries to observe or intercept it, the system knows, instantly. Here's how it works. Imagine two users, Alice and Bob. They want to share a secret, a cryptographic key. Instead of emailing or texting it, Alice sends a stream of entangled photons through a fiber optic cable or even a satellite link. Bob receives the other half. Because the photons are entangled, any change, even a single eavesdropper measuring a bit, immediately reveals itself. The transmission is disturbed. The secret is no longer secure. And they know it. It's like sending a letter that explodes the moment someone tries to read it. This isn't science fiction. It's already happening. In 2016, China launched the world's first quantum communications satellite, MISSIS. It successfully exchanged encryption keys between two ground stations 1,200 kilometers apart, using entangled photons beamed from space. In 2017, Chinese scientists achieved quantum-encrypted video calls between Beijing and Vienna. The era of quantum-secured communication had begun. Since then, the race has accelerated. Beijing now boasts a 4,600-kilometer quantum communication backbone, connecting major cities with entanglement-based encryption. The European Union is building its own EuroQCI. The United States has launched the Quantum Internet Alliance. Even commercial companies like Toshiba, ID Quantique, and BT are offering QKD solutions for banking, defense, and secure data centers. But what makes quantum communication truly revolutionary isn't just security. It's trust, or rather, the elimination of it. In today's systems, we rely on trusted third parties, certificate authorities, VPNs, centralized servers. But with QKD, trust is embedded in the laws of physics. It's mathematically guaranteed that if someone listens in, you'll know. That kind of security, provable, physical, unbreakable, has never existed before. And yet, it comes with challenges. Quantum communication systems are delicate. Photons can be lost in transmission. Fiber optics have distance limits. Satellites face alignment issues and weather interference. Building a large-scale, robust quantum internet means solving countless engineering problems, from quantum repeaters to error correction to global synchronization. But the prize? A network immune to eavesdropping. A military that can send commands with zero fear of interception. Banks that cannot be robbed via code. Governments that can secure elections, intelligence, and infrastructure with certainty. And, perhaps one day, a true quantum internet, where entanglement replaces copper, and information moves not through cables, but through the very fabric of space-time. It's no surprise, then, that the world's superpowers are racing to build it. Because in the wars of the future, power may not come from who shouts the loudest, but from who whispers the safest. If you found this story fascinating, like this video to support the series, and subscribe so you don't miss what comes next. A deep dive into quantum computing itself. How it could break the internet, solve impossible problems, and reshape everything from medicine to warfare. Because quantum communication is just the beginning. And the quantum revolution is only getting louder.